In this video, we're going to look at another improper integral where we've got an infinite discontinuity in the integrand. So we're being asked to look at the integral from 0 to 5 of w over w minus 2, dw, and determine whether or not it converges or diverges. We have to be a little bit careful because notice that the infinite discontinuity here is at 2, and we're going from 0 to 5 for integral, so it's pretty easy just to overlook that 2. But remember, in order to be able to apply the fundamental theorem of calculus, the function has to be continuous on the entire interval, and certainly w over w minus 2 is not continuous at 2. All right, so the first thing I'm going to do is I'm going to rewrite the integrand using long division, or just rewrite at the top as w minus 2 plus 2, and rewrite it so that I get something that looks proper as far as a rational function. So I got 1 plus 2 over w minus 2 in my integrand. I need to split it at 2, because that's where we have an improper piece here. I cannot plug 2 into my integrand. And then we'll replace that bad limit of integration with a variable, and then let that variable go to 2 in both cases. In the first case, the limit is the upper limit of integration, so the variable needs to approach 2 from the lower side or from the left. In the other one, the bad limit of integration is in the lower limit of integration. So when I go to 2 for that particular variable, it's going to come in from the upper side or the plus side. So I'll have that limit of the variable going to 2 from the right. And just like before, since we've got two integrals here, the variables have nothing to do with each other, so we need to give them two different names. So that's why I've got b for the first one and c for the second. All right. We're now able to evaluate this by just plugging in, doing an antiderivative and plug in our endpoints. Antiderivative for 1 is just w. Antiderivative for 2 over w minus 2 is log of 2 log of w minus 2 in absolute value. And then, of course, it's the same exact function we're integrating in the second piece. For the first one, you plug in b. We'll get b plus 2 natural log of b minus 2. When you put in 0, you get a 0 for the first part, and then 2 natural log of 2 here. So that's where the minus 2 log 2 is coming from. We have that second limit there as well with those with what we get when we plug in those values, but it turns out it's not going to matter. And the reason why it doesn't matter in this case is, remember, in order for this improper integral to converge, the original one, both pieces of how we split it up have to converge. If we look at this first piece, notice that as b gets really, really close to 2, the inside of the log function gets really, really close to 0, which means that 2 times natural log of b minus 2 is going off to negative infinity. That means that this original limit here does not exist. As soon as one of the limits does not exist, you're done, and we can conclude the original integral diverges.